Let's look at the solutions to the blue puzzle piece, Formative Assessment 6.1 to 6.2. Now, when you took this, the answers did scramble themselves, so they may not be in the same numerical order. So what you want to do, though, is just look at the learning objective letter, and that should help you. So my number one is 6.1b. How many possible outcomes are there in a sample space if there's a 12-sided die and a 6-sided die rolled? So remember, for that, all we need to think about is I have my die 1 and means to multiply die 2. That first die I have 12 options. That second die I have 6. Multiply it together, and that's where the 72 comes from. The next one, how many possible outcomes are there in a sample space of 5 coins are tossed? So I'm going to do coin 1 and coin 2 and coin 3 and coin 4 and coin 5. Each coin has a heads or tails or 2 faces, so it's going to be 2 times 2 times 2 times 2 times 2. That is 2 to the 5th, which is going to give us a total outcomes of 32. Now the next one here says to select all values that could be a probability answers. Couple things you want to remember about probability. Remember, probability is anything between 0 and 1. It can't be negative and it cannot be greater than 1. So A does work because that's just right below 0, or right below 1, sorry. C is going to be over 1, that doesn't work. E doesn't work. B will work. This is a fraction, it's less than 1. D doesn't work, but F actually does work. So those are the 3 ones that actually work in here. The next one is related to 6.1a. You have 2 fair 4-sided die are rolled. The faces of the die are numbered 1 through 4. Find the probability of getting doubles. Now, when I have 2 different events going on, that's where, again, I like to make my grid. So I'm going to go on in here and I'm going to do a 1, 2, 3, 4 for the first die. And then I will call this on over one here on the side, my second die. And if I just kind of visualize it, I could do this. Now, this grid is not the actual sample space itself. If you wanted the sample space, what you'd have to do is write out all the outcomes. So here's a 1, 1, a 1, 2, a 1, 3, a 1, 4, and so forth. And then the question wants to know, when are we going to have doubles? So sometimes I think it's almost easier to do this because then you can see right here where the doubles come into play. We could easily go ahead, and we notice on this one we're going to have doubles here, 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 and here. We have a 4x4 matrix, so there's 16 outcomes. So the probability of doubles is going to be 4 out of 16, which can be simplified to 1/4 as a final answer. The next one I have is 6.1c, understanding the difference between probability and relative frequency. So here we have a 6-sided die is rolled 300 times. Here's how many times they got a 1, 2, 3, 4, 5, and 6 of those 300 rolls. Compute the following. The probability of getting a 4, and I want it rounded to a decimal. Well, the probability is the theoretical answer. So on here, the probability of getting a 4 on a 6-sided die is going to be 1 out of 6. As a fraction, that's going to be a 0.167, so about 16.7%. The next question is, what is the relative frequency of getting a 4? Well, relative frequency is from chapter 1, so we look at our information here, and we're going to notice that the 4 showed up. It says here 80 times out of the 300 rolls, so we're just going to do 80 divided by the 300, and when you do that, you're going to end up getting the decimal of to 3 decimal places, 267. What would you say or would you say the dice are fair? So 300 rolls is quite a few rolls, a 16.7% versus a 26.7%. So there's a 10% difference. Here you would probably think that there's something up with the dice. They probably are not fair. There's something fishy going on. Maybe they're weighted to one side. In this case, maybe weighted more towards the 4, so that's why they're showing up more often. 6.2a, here we have, there are 35 students in Miss Ortiz's pre-calc class. One day, 24 students turned in their homework and 14 turned in their test corrections. 8 of these students turned in both homework and test corrections. Suppose we randomly select a student from class. First thing they want us to do is to complete the Venn diagram below here. H is the event, this circle, that they turned in homework. C is that they turned in their corrections. So to fill this in, what we know is that it says up here, 24 students turned in their homework, so I'm going to go on over to the Venn under homework and do 24. 14 turned in their test corrections, and that's going to be under the C, that's here. But be careful, it says 8 of these students that we've already talked about have turned in both homework and test corrections. So the intersection that we see right here needs to be 8. Now, because that's going to change to 8, what happens is when you read this circle now looks like it's 24 and 8, or it looks like it's 32 students. It's not 32 in total, it's only 24. So I need to actually come into here and adjust this. So this 24 now needs to become, take 8 away, 16. So that's 16, the intersection is 8. Again, we can only have 14 for the test correction, so I need to take 8 of the students out of here, and then I'm going to be left with 6. So now, if you were to tally up everything, our 16, our 8, and our 6, you're going to get 30 students. But she has 35 students total in her class, so that means if this is all 30 together, there's 5 that didn't do anything whatsoever, so the outside of this would be 5, and that would be your Venn diagram. Now the probability question here says, what is the probability that a randomly chosen student turned in neither homework nor the corrections? So this is homework and or corrections here. This is homework and corrections, that's 8 by the way. Homework or corrections is everyone, but neither homework nor corrections are these 5 sitting out here. So the probability for this part is going to be the 5 over 35 for that, which also does simplify to 1/7 if you want to do it that way. Now this slide is going to be looking at 6.2b, or probabilities where events are mutually exclusive. Remember, mutually exclusive means nothing in common. So here we have our the 2 dice. They're both the 4-sided dice are rolled. So I'm going to actually set up that sample space again so we can see that real quickly. We're going to have this scenario. I'm going to call this guy die 1 and this die 2. It doesn't matter which is which. Now they're going to walk us through setting this up first. The first question, probability of A. Event A is the first die shows a 1. So if this is my die 1, the ones that show a 1 for the first die are going to be here, 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 and here. That's going to get me 4 out of the 16 boxes that I have. The next one is the probability that the sum of the dice is greater than 6. So what you need to go and do is just add up the faces. Faces here would be 1 and 1 are 2. This would be a 3, 4, 5. Greater than 6 means that's 7. So here's a 6, and the first time we hit a 7 is going to be right here. So I'm going to come on over here. This one's a 7. The next one we're going to have is 4 and 3 and 4 and 4. So it's going to be 3 out of the 16. Now for OR probabilities, all you do is you add them together. So probability of A or B, you would add these two together. Now because I know they're mutually exclusive, there's nothing in common. You don't see any overlap. Now in OR probabilities, it's very important though. You look and see, did you double count? If you did, you back it out. We see nothing overlap. We see no double counting. And you can see the double counting by this. Look for, is the first die show a 1 and at the same time the sum of the dice is greater than 6. Never can the first die be a 1 and the sum is greater than 6, so it doesn't happen. Basically, or probability, just add these two together. So 4 plus 3 is going to give us our 7. So for this guy here, we're going to have our fraction is going to be 7 out of 16. Now the next question here says, if the events are mutually exclusive, we know they are considered to have, the answer there is nothing in common. So again, mutually exclusive means nothing in common, and we can easily see it in this grid. Now we're going to go to 6.2c, where the probabilities are not mutually exclusive. There's something in common. And here we're going to have a different scenario. We're going to flip a coin, and the coins don't have heads and tails, but they have the numbers 5 and 9 on each of the 2 sides, and it's a 6-sided die. So I'm going to set up that sample space real quickly over here. And we're going to see we have a 2x6 grid or something out of 12 for here. And again, their ultimate goal is to find the probability of A or B. So I'm going to write this down. The probability of A or B is always do the probability of A, then do plus the probability of B. But then I always think about, is there a probability of A and B? This is that when they're not mutually exclusive, okay? And that's what I'm going to help you walk through in these 3 parts. So let's do the first question. The probability of event A happening is the coin shows a 9. If you look at this sample space, if the coin shows a 9, I can see in this sample space it's going to happen here in these 6 events. So this is going to be a 6 out of 12. Okay, event B. What is the probability here? The sum of the face and the coin, the sum on the face of the coin and the die is an even number. So the sum of the face on the coin and the die is an even number. So you want to go through and sum up what these would all be and which ones are even numbers. Now again, this might help you if you want to write the sums, you can. So 5 and 1 is 6, this is going to be a 10, right? We're going to have 7 and 11, we're going to have 8 and 12. They want to know which ones are even numbers. So let's just write them all out. 9 and 13, 10 and 14, and then 11 and 15. So to find the even numbered ones, I'm going to look at this, and I'll just put a check mark. So we have 1, 2, 3, 4, 5, 6. It looks like we have 6 out of 12 again. Now, I'm double checking I didn't miss anything. That looks good. Now the next question is, what's the probability of A and B? So A and B is, what's the probability the coin shows a 9 and at the same time the sum of the face of the coins and the die are even. Now you can see that if you double check, if you double kind of checked anything on here or clicked it, right here we have both events happening, and both events happening. So in these cases what you're seeing, it says here the coin shows a 9 and the sum of the two items is even. So here it happens 3 times. So we do have that happening 3 times, which means we're going to have to back it out. So to find the ultimate probability answer, all we're going to do, probability of A is 6 out of 12, probability of B is 6 out of 12, probability of A and B is 3 out of 12. So that's going to simplify to give us 9/12. So 9/12 is also going to simplify to 3/4 for that one. And they want this type as a decimal to 2 places, so that is going to be a 0.75 as your decimal answer. And do be careful, the other blanks I'll ask for decimals too, so this is going to be a 0.5, a 0.5, and this top one, the probability of A and B is a 0.25. So make sure you had them in decimal format. The last question, kind of tucked away down here, is about complements. So it says there's a room of 45 girls with brown, blonde, and red hair. Let the event girls with red hair be event A. And they want us to do is state the complement of event A. So if event A is girls with red hair, what's the complement or kind of the opposite of that? So the various answers that would work for this, there are 2 of them. If our event is girls with red hair, the complement to that would be girls without red hair. So with that one here, girls not with red hair. However, there's another one, girls with brown and blonde hair would actually meet that same requirement. So this did have 2 different answers. There was one more question. Question 10 is 6.2F, computing probabilities with that. With complements. So here, there is a car lot with 89 cars. Let A be the event that there's blue cars. And here's the breakdown of the cars. 18 are blue, 10 are red. Find the probability of not selecting a red car. Okay, so they're telling us all this other stuff here. Some of it is filler information because really all they want to do is find the probability of not selecting a red car. Well, what we can do here is we know that there are 10 red cars in total, so that means 79 of the 89 are not red, so 79 over 89 would be our fraction for this. Again, don't let this trip you up that they're even talking about event A here being blue cars, because that really wasn't even relevant to the question. Hopefully these solutions help you better understand this formative assessment.